Okay, so what we did last time, do you remember? We tried to understand function from natural numbers to integer. And what was the function? Even number maps to positive integers and odd numbers in n map to negative integers, right? Is it clear? Yes. Is this clear? Did you understand this or? So what we discussed, we defined a function from natural numbers to integers. And what function we defined? The image of n. If n is even, then I will map it to n by 2. And if n is odd, then I will map it to minus n minus 1 by 2. Right. And we proved that then f is 1 1 and onto function. So this function is 1 1 as well as onto. Right. So therefore this function, there is a bijective function from natural numbers to integers. Right. So as we defined before, uh, what we call if A is a set, then what is the cardinality of set A?
Number of elements in set A.
Right. So is we denote this by a symbol. This.
Set value of A.
So the number of elements in set A. Right. So how many elements are in this set? So that is denoted by this modulus of A, which is called as cardinality. Right. So cardinality of set. Fine. So now if there is a bijective function, or I will say there is a bijective function f from A to B if and only if cardinality of A is equal to cardinality of B. So two elements or two sets have same number of elements if and only if there is a bijective function from A to B or B to A, same thing. Right. So do you understand what I have written? Statement is clear?
Yes, sir.
Yes. So for example, uh, suppose A is set of 5 fruits and B is set of 5 people or students, whatever. Now, does there exist a bijective function from A to B?
Yes. Yes, sir. Yes.
Right, so there is a bijective function from A to B. Suppose I have five fruits. A is fruit 1, fruit, or what I will say, A1, A2, A3, A4, A5, and B is a set of five persons, P1, P2, P3, P4, and P5. These are names of these people. Five people. So I can define a bijective function, and there are many. How many bijective functions are there from A to B? How many ways we can distribute these five fruits among five people? You understand? Question is clear?
5 factorial.
So, right, 5 factorial. How many ways I can distribute 5 fruits among 5 people? So, that means how many bijective functions, right? This is equivalent to saying that how many bijective functions are there? How many bijective functions are there from set A to set B? Right. So this the question is equivalent to saying that how many, because how many ways we can assign, right? So A1, A2, A5, and P2, P5. So how many ways I will suppose first fruit I will give to first person, second I will give to second person, and fifth I will give to fifth person. This is one way. What is another way? I will give first fruit to second person. I will give second fruit to third person. I will give fourth fruit to fourth person. And I will give fifth fruit to first person. This is bijective function. Do you understand? Yes, right? So if your mic off, Sairaj. So if you want to talk with me, then only keep your mic on. Otherwise, keep your mic off. Okay, so how many do you understand? We want to define bijective function from set of fruits to set of people. That means we want to distribute fruits to the among these people. And how many ways? So how many bijective functions? So what is the answer here? What is the answer?
3 factorial.
5 factorial, or
Yes, yes, 5 factorial.
because A1 has how many choices? 5. A2 has only 4 choices because one person is already occupied by fruit A1. So second has only 4 choices. Third has only 3 choices. Right. Fourth has 2 choices and fifth has only 1 choice. And therefore total choices is 5 into 4 into 3 into 2 into 1. So it is 5 factorial. So how many ways I can distribute 5 fruits among 5 people? So 5 factorial, that means 120 ways. And you think about it. Why? Right. So you should spend some time on thinking of such questions. Right. So there are 5 factorial 120 ways I can distribute. So how many bijective functions? That is important point for us as this moment. Right. So there is a bijective function from A to B if and only if their sets have same number of elements, same cardinalities. Now question I would like to ask, if we have 4 caps and 6 people. Does there exist bijective function from set of caps to set of people?
No, sir.
Right? Does there exist a bijective function
No.
from set of caps to set of people?
No.
Set of 4 caps to set of 6 people. And answer is no, right? Because we have only 4 caps and we are going to distribute among 6 people. It is not possible. We cannot cut a cap and distribute same cap to 2 people. That is not possible. So there is no bijective function. So therefore, if we have n caps, we have a set A of n caps and a set B of m people, right? So if you have a set A of n caps and set B of m people, then there is a bijective function if and only if what?
N is equal to M.
Right. Then there is a bijective function f from A to B if and only if m is equal to n. If m is equal to n, no doubt, I will assign one cap to one person. That is easy. But this is possible only if the number of caps and number of people is same. Right. So here our sets are finitely many elements. But what we observed
And
in
so if
the previous, right? Pardon? Okay, so because what is my problem? I have a caps and I have some people, and then I want to distribute all the caps, and no person is left. Everybody should get a one cap, not more than one caps when it is possible, right? So question is a very simple. I have some number of caps and some number of people, and I want to distribute every cap to the one person, right? Every person should get a cap. No person should get more than one caps, and no person is left. So this is possible only if the number of caps is same as number of people, right? So that distribution is a function actually, one-to-one correspondence. And the example which we discussed last time, there is a bijective function. So since there is a bijective function f from natural numbers to integer, is it true? Is it true? There is a bijective function from natural numbers to integers. Is it true?
No, sir.
yes,
Right.
also
So what can I say from this? From our previous discussion, we say that, can I say that cardinality of natural numbers is same as cardinality of integers? Right? Cardinality of n is same as the cardinality of integers. So this is a strange thing because our sets are infinite, and in infinite case, if uh, as a set, note that as a set, as a set, n is a subset, proper subset of Z. It is a proper subset, but as far as if you count the number of elements is same. This is what the different in infinite set. In finite case, it is not possible, right? In finite case, if I have four caps and six people, then there is no bijective function, right? Do you understand? If I have four caps and six people, there is no bijective function because our set is finite, right? Set of caps is a finite, set of people is finite. In that case, it is not possible. But infinite case, this is possible. Ki if you are directly, if you see the set, there are less elements. But as if you count the elements, number of elements is same. That is what the power you want to this bijective function gives. Is it clear what I said?
So can you just repeat one thing? I think I missed it. N is a proper or an improper subset of integers?
Yeah, as a set, proper means what? A is a proper subset of B. Means what? A is subset of B and there exists B in B which is not in. There exists B in B such that B is not in A. Right? For example, if A is equal to A, B, C and B is equal to A, B, C, D. Can I say that A is a subset of B? Yes.
Yes, sir.
Yes.
But A is a proper subset because there is some extra additional elements in B. Because D is in B, but D is not in A. Right? There are some more elements. That means it's a proper subset. Correct? Do you understand? If you look at natural numbers, what are natural numbers? 1, 2, 3, and so on. What are integers? All negative, -2, -1, 0, 1, 2, and so on. And if you compare these sets, so natural numbers is a subset of integers, no doubt. And -1 is in integers, but -1 is not in natural numbers. Do you understand? Yes. Therefore, what I can say, natural numbers is a proper subset of integers. Is it clear? Is this clear or not?
Yes, sir. Clear.
Yeah. But still, a natural number is a proper set. If you count the number of elements, it is same because there is a bijective 1, 1. I can distribute one number with one integer. I can assign one natural number with one integer. So it is possible actually, and that possible what made possible the function which we defined before that made it possible. Right? Okay. Now, next question I would like to ask. Let A is equal to 2, 3, 4, 5, 6, and so on. All natural numbers after this. And n is a set of natural numbers. Now I am going to ask a very simple question. Does there exist a bijective function f from natural numbers to a? The question is very simple. Do you understand A is a proper subset of n? Do you see
Natural
this?
numbers.
Easy, right? So note here, A is a proper subset of natural numbers. Do you see this? you see this or yes? Because which element is not in A1, right? Because 1 is in natural numbers, but it is not in A. And all other elements. So A is a subset of N, and it is a proper subset because in N has some more elements, extra elements, right? 1, for example. So, does there exist a bijective function from natural numbers to A?
No, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
What is that function?
F of x equals to x plus 1.
Very good. F of x is equal to x plus 1. So ultimately what I am doing, so I have set of natural numbers 2, 3, 4, 5 and so on. And what my set, I have set of set A 2, 3, 4, 5 and so on. This is my set A. What I am doing, so okay, I see that I where 1 to be mapped, 1 but no element is available, so I will just shift here. I will shift it here. I will shift it here. Continue this process. Right? Because how many elements are in set A? How many elements are in set A? Infinitely many. So there will not be a situation such that for some element in N, no element available. So that situation is not will not arise. So okay, I will give you a simple example. Okay, suppose there is a conference and infinitely many people came for conference and some chairs are assigned. Right, so first person, second person, third person is assigned with this chair, right? Fourth person is assigned with this chair and so on. How many people came for conference? Infinitely many. And therefore, how many chairs are there? Every person is assigned with some chair. And how many chairs are there?
Infinite.
Infinitely. Okay, so in between there is a lunch break, suppose. And what happens? All people went for lunch break, right? And then some in between some person removed, suppose first chair. Some person removed the first chair, and the people came back. People came back after lunch, and they found that his first chair is missing. Okay, so first chair is missing. What will happen? Will everybody get a chair? How many chairs are there? Basically, infinitely many. One chair is missing now. Can you see the picture? I have written something. I have drawn some pictures. Can you see this picture? Okay, how to solve the problem now? Because every person, every delegate should get a chair, but one chair, first chair is missing. What will be the what to do then?
Shifting by one.
Hmm?
Shift
Yes,
every person by one.
yes, exactly. Get shifted. First person will occupy second chair. Second person will occupy third chair. Third person will occupy fourth chair. Keep on doing this. Will the situation arise that all chairs are finished? Will such situation arise?
No.
No,
No.
because there are actually infinitely many chairs, and therefore no problem if you somebody taken away some chairs, not an issue. Just get shifted, and that is what this function is. Right? What is this function actually? So one number is missing, no problem. Just shift. And what is the shifting process? X plus 1. X will go to x plus 1. This is a shifting process. Alright, such map function is called as a shifting. Why it is called as a shifting? Because of such kind of situation. Shifting. So shift to the next. Right? So every person will get a chair, exactly one chair, and this is a 1-1 correspondence. It is a bijective map. So if I define a function from natural numbers to A, our set A by f of x is equal to x plus 1, can you say that it is a 1 1? Then f is 1 1. Why? Why f is 1? How will you prove that this function? You know what is our set? Set A starts from 2, 3 up to infinity. Why f is 1 1? Why f is 1 1? How to prove f is 1 1?
Every element in the set of natural number is having image in the A set.
Every distinct element should have distinct images. Right? If elements are distinct, their images should be distinct. Right? Distinct elements should not have same image. Such situation is not should not be there. That we want to see. Suppose m and n are natural numbers. If m and n are distinct, then what can you say about f of m? By definition, it is m plus 1. And what is f of n? Is n plus 1. And therefore, can I say that their images are also distinct? Can I say this?
Yes,
Right?
sir.
If m is not equal to n, then m plus 1 is not equal to n plus 1. So clearly images are distinct. Alternatively, suppose f of m is equal to f of n. Suppose images are, that means m plus 1 is equal to n plus 1. Means what? If you cancel 1, m is equal to n. So if images are equal, then pre-images are also equal. So hence f is 1 1. F is 1 1. Is it clear?
Yes.
Now why f is onto? Why f is onto? Okay, go to the our back process. For example, what we want to prove, for every element in codomain can we produce pre-image? For example, what is the pre-image of 4?
3.
3. What is pre-image of 10?
N minus 1.
Right. So in general, what is the pre-image of m?
M minus 1.
For
Minus
m
1.
belongs to A, there exists n, which is equal to m minus 1 in natural numbers. For every element, is it true? So
Yes.
say that f
Yes,
of
sir.
n, that means f of m minus 1 is m minus 1 plus 1, which is n. So you choose any element from A, certainly, because 1 is not member of A, so there is no question about 0. Okay. Therefore, for each y in A, there exists x in n such that fx is equal to y. Therefore, and hence f is a bijection. Right. So because f is 1 1 and onto. Right? F is a bijective function. It is 1 1 and therefore can I declare that the number of elements in A is same as number of elements in N? Can I declare now? Because what is my basic definition of equal cardinality? If there is a bijection. Do you understand? Am I right? What I have written, is it clear?
Yes, sir.
Because there is a
Yes.
bijection between set A and N, and so they have same number of elements. And what actually happening, what it suggests, N has infinitely many elements. From infinitely many elements, if you remove one element, the number of elements same. That means infinity minus 1 is always infinity, right? You understand? So from a sea, if you remove one glass of water, how much water left with in sea, in ocean, right? This is the same philosophy. From ocean, if you remove one glass of water, how much water left with ocean? Correct? Right?
Yes, sir.
Okay, so do you understand? It is something you should be able to relate this with our real life situations. In infinite situation, if you remove one element or two element, then also not an issue. Suppose if you look at the same problem, suppose some person remove first two chairs. Suppose these first two chairs are removed, and then people came back. Is it possible that everyone will get a chair?
Yes,
Yes,
Yes.
yes,
shift
sir,
by
it is.
chairs. Somebody removes three chairs. Then also it is possible, no problem. Shift by four chairs. So this is something interesting that you should notice. But now I want to state the problem in different way. Suppose one, two, three. So infinitely many people occupied infinitely many chairs. They went for lunch, and what happened? Some person removed the fourth chair. All other chairs are there. What happens?
Um,
Fourth chair is missing now. All other chairs are there.
Sir, in that case, f of x is equal to x plus 1 for x greater than 3.
Right. So when people came back, then first person will see that okay, his chair is available. He will occupy his chair. Second person will occupy. Third person, but fourth person will be in trouble because his chair is missing. So what we'll do? We'll occupy fifth chair. Fifth person will occupy sixth chair. Sixth person will occupy seventh chair, and continue this. So then problem is solved.
Sir,
Yes.
what if someone removed all the occupied chairs?
Then that is the very then it is not possible, right? If you remove everything, then how it is possible? What I am saying is, if I remove one chair, suppose somebody removes two chairs, three chairs, then that's in that case there is a bijective function, right? But if you remove all, then that situation is uh, trivial situation. There is nothing at all, no function, right? Because no person will get a chair if there is no chair, right?
so, sir, we can remove any finite number of chairs and we'll still be okay.
Yes, this is the uh, general statement. What is a general statement? If a set of natural numbers and A is a finite subset of finite subset of n. You choose any finite subset of n. Then B is equal to n minus A. Do you understand what is the meaning of n minus A? Not in A. That means remove elements from A. Then there is a bijection from N to B. So somebody removes three chairs, somebody removes four chairs and seven chair. What will be the situation now? Six person what will do? Because fourth person will occupy fifth chair and fifth person will occupy six, but six chair is and sixth person will occupy seven, but seven chair is also missing. Then he will occupy next. Go shift next. For finite, if you remove finitely many chairs at a time, then not an issue. Right? Okay, so you think about this statement. This is something interesting you should think about. Okay. in infinite case, if you remove finitely many elements, the cardinality is not going to change. What it suggests, the cardinality of n is same as cardinality of b. This is the point we should understand. Right? Can you find a bijective function f from natural numbers to rationals set of? So you think about this. Can you find a bijective function from natural numbers to set of rational numbers? Right, this is a big question. Not very big, not very difficult, but you should think about it. Maybe later on, perhaps we'll discuss this because you need to think about it. If possible, then what we can declare? If answer is yes, then what we say that if S, then we can say that number of elements in n is same as number of elements in rationals. This is a very interesting thing. How many rational numbers are there if answer is S? Then we'll declare that natural numbers and rational numbers are equal in amount. Right, that is interesting. Anyway.
Sir, sir,
Yes.
sir, f of x is equal to 1 upon x, where x belongs to n.
But that will not cover all the rationals. How will you cover 2 by 3? Yes.
Yes, sir.
Right, so it will not cover all because we want bijective means 1 1 and onto map. That means every element in this set, distinct element goes to distinct element, and it should be onto means range should be whole codomain. So everything in codomain should be covered by elements in domain. Right.
So we can try a bijection from n to n cross n.
Yeah, that is again okay.
We can just say that if it is if the n cross n is x comma y, then this represents the rational number x by y.
Can you find a bijective function g from n to n cross n? This is another question. Right, so you just think about it. It is, we are not worried about this question right now. You think about it, and then we'll discuss, because immediately it is difficult, right?
Sir,
Yes.
so can we use the definition like P by Q such that P and Q are not equal?
Yes, rationals are, because what is a set of rational numbers? P by Q.
I mean, sir, we can use the definition as the function f of x is equals to P by Q such that P and Q belongs to n. Q
No,
is
no, no.
not.
That is okay, but which natural number map to which P by Q, that should be well defined. That makes sense, right?
Okay, sir.
What I want to say, if you look at the previous example, see this example, f of x is equal to x plus 1. So I know where 1 is going. Where 1 mapped to, do you understand this? Where 2 is mapped 3. Where 100 is mapped under this map 100. And so I have definite information which element of domain going to which element. So that is what the meaning of well-definedness. Right, when we define a function, then we should have confidence ki I know which element is going to which element. Right?
Yes, sir, I understood.
Yes, so very good. So you just think about such problems, because I am not expecting you should answer it immediately, because this is a something difficult thing at this point. But anyway, my question is, Next question I would like to ask. Can I have function functions from R2 to R? Right, so can I define function from R2 to R? Do you understand? Okay, what is R2? Do you understand what
Real numbers related to themselves.
R cross R. So R not I am not saying simple R, it is real numbers R, right? R cross R. What is this set R2 or R cross R? Pairs, right? And what we how do we identify these elements? So XY plane, right? So for example, 1 comma 2 is here, so this is member of R2. So all points in the plane, right? So all points in the plane is the set R2, correct? Right? Yes. Do you understand what I am saying? And what is R? R is set of real numbers. Right, and R we say that it is a real line. This is R and this is R2. Now, what is a function? Function is a map from one set to another set. So these are two sets now, R2 and R are sets. Do you agree? Do you agree that R2 and R are two sets?
Yes, sir.
Sets. Now, can we define function?
Yes.
Can we define function? Certainly we can define, because whatever sets we have, we can define. Suppose I have 5 elephants and 100 trees. Can I define a function from set of 5 elephants to set of 100 trees? Yes. I will map some first elephant to this particular tree. I will map second elephant to some particular tree. No problem. Whatever sets you have, you can always define a function. That whether it is a one-one function or onto function, that is a different story. But as far as function is concerned, whatever sets we have, I can define a function, right? Yes. Do you understand what I am saying? Okay, can you tell me some function from R2 to R? Okay, use just simple knowledge, and I want to map points, right? Elements in plane to some numbers here. Some real number. I want to map point xy to some real number here. So how do I define function from R2 to R? So how do I write it? I want to map, because what are the elements in R2? Pairs xy, right? And it mapped to some real number. So for example, x plus y. Is it a function from R2 to R? Basically, is it a function?
Yes.
Yes,
Yes.
it is a function.
Because you give me any element from R2, any pair xy, I can apply a function and you get a real number. Right. For example, what is if xy is equal to 1 1, right? It is member of R2 domain. And what is f of 1 1? By definition, how do I define function? F of xy is mapped to. How do I define function? Xy is mapped to x plus y. I am adding components. This is what. So, what is image of 1 1?
2.
The image of 1, 1 is 1 plus 1, that is 2. And is it a real number?
Yes.
Right. That means this is, you understand, this is a function. And what is f of 3 comma 10? So 3 plus 10, it is 13. So therefore, 3 comma 10 is a pre-image of 13. Right? 3 comma 10 is a pre-image of 13, or 13 is the image of 3 comma 10. So that you can understand. You can apply this function to element in R2, it immediately gives us a real number. So this is a function from R2 to R. Right. So is it 1-1 function?
No.
No.
F11. Why? Can you give me two distinct elements having same image?
X comma y, x1 comma y minus 1.
Yes. No. If I look at 1 comma 0, x1 y1, and I will look at another point x2 y2 is 0 comma 1.
0, comma.
Right, these two are distinct elements. These two are distinct elements. Am I right?
Yes.
Yes.
Because x1 y1 is not same as the element x2 y2, because in the plane where is the position of 1 comma 0? Position of 1 comma 0 is here, and where is the position of 0 comma 1? Position of 0 comma 1 is here, and therefore they are distinct elements clearly. But what is f of x1 y1? What is f of x1 y1?
1.
1 plus 0, that is 1. And what is f of x2 y2?
1.
Right?
1.
Ultimately what we get, therefore f of x1 y1 is same as f of x2 y2. What does it mean? Distinct elements map to same element, their image is same. That means I have two distinct elements x1 y1 x2 y2, but their image is same, which is 1. Right? And so therefore what I can say, f is not 1. This is an evidence. This is evidence where distinct elements are mapped to same element. One evidence is sufficient to say that it is not 1-1. If there is no such evidence at all, then we'll say that it is 1-1, right? Do we agree? Yes. Do you agree what I am saying?
Yes, sir.
Right. So therefore this function is not 1-1. But is it onto? See, our function is from R2 to R. And what is f of xy? X plus y. For example, so for
Yes, sir,
z
it is on to.
for z belongs to R, can we produce xy in domain such that f of xy is equal to z for any z, right? For any z in codomain, can we produce xy in code in domain such that the image is? So for example, if I take z is equal to 10, then what is xy? What is xy?
7, comma 3.
Right, because 10 I can write it as 7 plus 3. right? And therefore if I take xy is equal to 7 comma 3, then what is f of xy is 10 or 3 comma 7, right? How many? There are many possibilities, many pre-images, right? I can also say that 10 is equal to 13 minus 3, or I can also say that so that I can catch element xy is equal to 13 comma minus 3, right? I can also say that it is 10 is 27 minus 17, so I can look at element 27 comma minus 17. So there are many possibilities for pre-image. That's why function is not one, right? But certainly for every z I can produce pre-image. So in general, these are just particular examples to understand, but in general, for z in R, what is xy is equal to z minus a comma a. You just fix any a and look at the element z minus for some a. You choose any real number a and subtract from z and take it as a first component, a as a second component. Then what is f of xy? Then what is f of xy? Right? Do you understand? That's how I created this element 7 comma 3. 10 minus 3 plus 3. And so which element I look at? 10 minus 3, 3. That is 7 comma 3. That is the easiest element we can immediately produce. There are many elements, right? Correct? Therefore, f is on 2. Now, question I would like to ask, what is f inverse of 10 or what is f inverse of 1? Inverse image. Here what we saw, ki inverse image of what is f inverse of z? What is f inverse of z? Is those points xy in domain whose image is z, right? Those points in domain whose image is z. Do you understand? Inverse image means what? We have domain, we have codomain, and this is z. So what is inverse image of z? That is f inverse of z. Yes, do you understand? Is it clear what I have written? If you have any doubt, you ask me.
Can you explain F inverse again?
Inverse means what? Inverse image. Okay, for example, I have A, B, C. I have 1, 2, 3, and this is my function f, A to B. Right. Suppose what is my function? A goes to 1, B goes to 2, C goes to 3. That means f of A is equal to 1, f of B is equal to 2, f of C is equal to 3. That means what is the inverse image of 1 or pre-image of 1?
A.
Right. That
A.
means so pre-image of 1 is A. That means f inverse of 1 is A. F inverse of 2 is B. And f inverse of 3 is C. That means inverse. If you go back from 1, then what we see A. Right, inverse image. Do you understand now meaning of what is inverse image?
Yes, sir.
In our previous function, what is inverse image of 1, for example? What is f inverse of 1? It is a set of elements in domain whose images, right? Because why f inverse of 1 is A? Why f inverse of 1 is A? Because f of A is 1. Right? Why f inverse of 2 is B? Because f of B is 2. Do you understand?
Yes, sir.
So xy is in f inverse of 1. Xy is f inverse of. It may happen sometimes. Sometimes you may have many inverse images. For example, A, B, C, D, 1, 2, 3. So I define this map like this. Right. Right. So is it a function from A to B? This is a function. Correct? F of A is 1 and f of B is also 1. F of C is 2. F of D is also 2. Fine. Now what is F inverse of 1? In this case, what is F inverse of 1?
A.
A,
A and B?
A.
yes, A
A.
and B.
Because one has two inverse images, pre-images. Therefore, inverse image of an element is a set actually. It may have many pre-images. Right?
Yes, sir.
F inverse of 2 is
C
C
and
and
D.
D. What is F inverse of 3? Empty set?
I.
Because 3 has no inverse image at all. Do you agree?
Yes, sir.
Yes. Okay. Now
Yes, sir.
what what is our function? Our basic function we are talking about is f of f from R2 to R. We are interested in that function. So what is my function f from R2 to R, and f of xy is x plus y. Then my question is, what is f inverse of 1? This was my question, basic question. What are the points which are inverse image?
0,
Images.
1.
0, 1
Comma
and
0
1,
and
0.
0 comma 1.
You are right, but is it the only, these are the only points or there are many more? Can you get clear idea?
Many more points are there.
Let us see. What is by definition, what is f inverse of 1? Those points in domain whose image is 1. Am I right? Let us go step by step. Then you can understand it clearly and you will get the clear picture. So those points xy in R2 such that f of xy is equal to 1. But what is f of xy? X plus y is 1. Now you got clear picture what is inverse image. Do you see something bigger set? What are the points in R2 satisfying this condition f of xy is equal to 1 or x plus y is equal to 1? So what is x plus y is equal to 1?
So there are infinitely many points.
And can you get
You can say
clear?
that it's a line.
Right. That is the main point. All points on this line x plus y is equal to 1 will satisfy this condition, and therefore all points on this line, every point on this line and exactly all the points on line are is inverse image. And therefore what is inverse image of 1? The every line, every point on this line. This is an interesting thing, right? Correct? Yes. Is this clear?
Yes, sir. But I have to ask just one thing. F
Yes.
inverse won't be a proper function, right?
F, no, I am not saying f inverse is a function. I was just looking at inverse image of 1, right? What is F inverse of 10? What is F inverse of 0? You just think about it. Find it out. Not difficult actually. Right? Yes. Now I want to define F from R2 to R2. Can we define function from R2 to R2? That means if I have element in R2 and I want element in R2. Is it possible? For example, f of 1 comma 2. What is f of 1 comma 2 in this case? X plus y, x minus y. Yes,
3 and minus 1.
right. X plus y, x minus y. So 1 plus 2, 1 minus 2. So it is element. So if I apply function on elements in R2, I get element in R2 again. So this is a function from R2 to R2. Right. So you think about this function. Next time we'll discuss more about this function. Right. And you just think how this function is, how is it 1 1, is it on 2, how to produce pre-image, is it 1 1. So you just think, try to think about it. Next time we'll discuss those so that you can understand. If you think, then you can understand better next time. Right. Any doubt? I think we should stop here.